Welcome to this explainer. You probably stare at it for literally hours every single day. That sleek metal and glass device sitting right in front of you. But beneath that keyboard, it's a microscopic metropolis operating at light speed. Today, we're opening up the black box. We're taking an anatomical journey, traveling from the very outside of your machine all the way down into its beating heart. I actually want you to look down at your laptop for just a second. Think about this. What actually happens inside that device when you simply swipe your finger? I mean, it feels totally instantaneous to us, right? But the reality is that your simple physical movement kicks off this massive, highly coordinated chain reaction across millions of tiny pathways. So let's trace that journey right from the point of contact.
Okay, Section 1, your gateway, the touchpad.
Let's dive right into this, starting in the tactile world, right at the starting line. A touchpad or, a trackpad or a glide pad acts exactly like a traditional mouse, but it's built directly into your laptop. As your finger glides across the surface, it maps your physical intention into digital movement. It's your literal input gateway. It's how you hand your instructions over to the machine. But once you tap or swipe, where do those instructions actually go?
Which brings us to Section 2, the computer's brain, the CPU. We're traveling straight down into the command center now. If your computer is a bustling city, the central processing unit, or CPU, is absolutely the mayor. You likely know the famous ones, right? Intel, AMD, Apple, ARM. As the undisputed brain of the operation, its entire existence revolves around grabbing the input you just provided, executing your demands, and generating the visual output on your screen. And it does this mind-blowing feat in literally a fraction of a millisecond.
To pull this off millions of times a second, the CPU relies on a relentless 5-step loop. It starts by fetching your instructions from temporary memory. Then, it decodes them to understand exactly what you want it to do. Next comes the heavy lifting, executing the math or logic. It immediately stores those results so you can see them. And all the while, it's managing sudden interrupts, like a text notification popping up, without missing a single beat.
Moving right along to Section 3. Inside the microprocessor.
Let's zoom our microscope in even further here. The speed of your computer actually comes down to 3 distinct departments working in perfect harmony. You have the manager, that's the control unit, directing traffic and communicating with the rest of the computer. Then there's the mathematician, the arithmetic logic unit, crunching the raw numbers. And finally, the temporary lockers, the registers, holding the immediate data being worked on right this very second. When your computer freezes up because you have 50 browser tabs open? Well, it's often because these tiny lockers are totally overflowing.
That takes us to Section 4, the motherboard backbone.
So the really crucial point here is understanding the foundation of it all. If the CPU is the mayor and its departments are the city hall staff, well, they need a physical city to govern. That land and infrastructure is the motherboard. Technically known as a printed circuit board, it is the literal backbone of your computer. It securely hosts the CPU, your memory chips, and your sound card, acting as the ultimate connector hub so every single component can seamlessly talk to one another. The motherboard makes this massive collaboration happen through 3 vital types of connections. First, you have the physical sockets and expansion slots securely holding the hardware in place. Then there's the electrical network, distributing precise, tiny voltages of power from the wall outlet to every individual chip. And tying the whole shebang together are the communication hubs, specialized chipsets like the South Bridge and North Bridge that act as data superhighways across the entire board. Now for our final stop, Section 5, data buses and memory.
Now, what's really interesting about this part is how the traffic actually moves. We have our city and we have our mayor, but how do the instructions travel? They move on data buses. These are parallel electronic pathways linking the CPU, memory, and your peripherals. They're basically the communication pipelines handling the incredibly high-speed exchange of digital data, and they adjust their speeds dynamically depending on exactly what you're asking the computer to do.
The capacity of these pathways really just comes down to their width. Think of it exactly like lanes on a highway. A narrow data bus is like a 1-lane country road. Fewer bits travel at once, creating massive traffic jams and slower performance. A wide data bus, on the other hand, is a massive 8-lane superhighway, ensuring a huge flow of information. Honestly, this is the hidden secret of why a more expensive, high-end computer feels so incredibly fast and snappy compared to a budget model. It literally just has wider roads. Which brings us to our final puzzle. The CPU is the brain, the buses are the nervous system, and the motherboard is the skeleton. But if those CPU registers are just temporary lockers that eventually empty out, where exactly do all of your computer's permanent memories, your photos, your documents, your operating system actually rest when you pull the plug for the night? What makes them survive the darkness? Think about that the next time you power down. And we'll explore exactly where those memories live next time.